Here's problem 21.6. A 50-gram sample of dry ice, solid CO2, is placed in a 4-liter container. The system is sealed and allowed to reach room temperature, 20 degrees Celsius. By approximately how much does the pressure inside the container increase when the dry ice turns to gas? Ignore the initial volume of the sample. Let's find out how much of this sample that we have. We have the mass is equal to 50 grams. And if we're dealing with carbon dioxide, CO2, the atomic number of carbon is 12 and the atomic number of oxygen is 16. So the molecular mass, molar mass, or the molecular weight of carbon dioxide will be equal to 1 carbon and 2 oxygens, 44 grams per mole. So we can calculate how many moles we have. The number of moles will be equal to our total mass divided by the mass per mole, molecular weight of carbon dioxide. So that would be 50 divided by 44, and that will give us 1.136 moles. Alright, we have a closed container, and there might be a pressure in this container, but as this dry ice sublimates into extra gas, whatever additional pressure we have in this container is going to be due to just the CO2 gas that's been produced. So our change in pressure is going to be the pressure due to this gas. Alright, we note that our temperature is 20 degrees Celsius, so that's going to be 293.15 Kelvin. And we know from the ideal gas law that PV equals nRT. So let's find this pressure due to this gas. That's going to be equal to nRT divided by V. So that will be, we have 1.136 moles. Now, which R constant do we want to use? Well, we're given the volume in terms of liters, so we want to use the other R constant, 0.0821, which will give us volume in liters and pressure in terms of atmospheres. Temperature is 293.15, and like we said, we were given volume as 4 liters. So this will give us an answer in atmospheres. I get 6.84 atmospheres. That is the additional pressure contributed by the CO2 gas, and so that will be the change in pressure over whatever pressure we had to begin with because of these extra gas molecules in the container. 6.84 atmospheres.